Okay, so once you mastered the mole-to-mole stoichiometry problems, our next part is to master the mass-to-mass stoichiometry problems. And this is not any different than what you've just done, except you're going to have to do a few more steps. Okay, the key to mass-to-mass problems is not to be overwhelmed about it. You already know how to do all the pieces to the puzzle. You're just going to now put those pieces of the puzzle together. You already know how to convert grams to moles using the molar mass conversion. You already know how to do mole to mole conversions using a balanced equation using molar ratios. And you know how to go backwards from moles to grams, again using the moles to grams conversion for converting moles to grams using the molar mass. So you already know how to do all the pieces. You're just going to link them together now. So the first thing you want to do is you balance your equation if you haven't done that already, or the equation is not balanced. Then you're going to change from grams to moles using the substance molar mass. That's your start point. Once you have the moles for that, you're going to convert the moles of your starting material into the moles of your want material, your desired material. Once you do that, now you have moles of your want material, and you're just going to convert that back into grams using that material's molar mass. So basically what you're doing is you're going from grams to moles, using the molar ratio to go from one material to another material in the balanced equation as far as moles, and then moles of that new material back to grams. Okay, if you remember from the page before, the slide before, I said we're doing three different calculations. We're going from grams to moles, moles to moles, moles to grams. So if we would set it up as a standard picket fence or dimensional analysis thing, we start out with grams given. We use the molar mass to convert to moles. So once we have this calculation done, we have moles given. That answer is the start point for our next thing, which is the mole to mole conversion, which we just did. So moles given, using the molar ratios from the balanced equation, we convert to moles of want. So we're converting here from moles given to moles of want. Once we have moles of want, that's the start point for the last conversion. Moles of want times the molar mass of that material gives me grams of material that I want. So I'm going from grams given to grams want through this three-tiered or three-step calculation. Now, we can do it in one step. Okay, so let's see how this one continuous process here is just basically the three individual calculations all at once that we just talked about. Now, there's no reason why you have to do it all in one calculation. You can do it in three different calculations if you want. I'm trying to save you time and make it more efficient. But if you feel that this is too much, then do each individual calculation. Just make sure that the answer from one is the start point for the next. So let's see what we mean by that. So in my first thing here, if I go from this block to this block, this is going to give me grams given, and I'm going to use the big G circle for given, to moles of given. At the end of the day, if I stop the calculation right here, if I put all these things in and I stop my calculator and stopped here, I would have moles given. The next thing we want to do is, that's the start point for this calculation, and so we're going from moles given, and we're going to convert over to moles want. So that's that conversion. And then the last one is, if we do this calculation here, remember this is moles want, so that's on the top. Remember, this could be a 1, this is on the top. Now we're going from moles want to grams want. And there you have it. So these are each individual calculation. First calculation, grams to moles, moles to moles, moles to grams. You just learned how to do this, you know how to do this, and you already know how to do that. Piece of cake, right? So don't worry or fret about it. If you can't do all this in once and know where to set it up, do it this way. Now, I'm going to tell you that this setup right here is exactly the same for every gram to gram stoichiometry problem in chemistry. There is no other way to do it. You start out with grams given, convert it using the molar mass into moles, use the mole ratio between the want and given, and then finally you convert back to grams using the molar mass of your want. Every gram to gram problem is done exactly the same way. The numbers here obviously will change, but the process and the setup is exactly the same. There's no other way to do it. So if you can memorize or understand that this is the same for every mass-to-mass problem in chemistry for stoichiometry, you're golden. All right, so let's use the continuous process to solve this particular equation. Now, we're not going to get a number on this page. I'm going to show you how to set it up, and then we're going to use the next side to show you the number. So here we go. Let's look at it this way. First thing we got to do is figure out what is our given and what is our want. So I'm going to read the problem, and I'm going to see that in this case, this is our given. This is our given right here. 300 grams of C3H8. So by definition, the given goes in this box here. So we're just going to write 301 grams of C3H8. And then we're going to put that over 1. Now, we have to convert from what to what? Grams of C3H8 to moles of C3H8. Because remember, all the chemistry is done in moles. We just weigh stuff out in grams. So, since it says grams of C3H8 up here, that, by definition, has to be written down here. Just like we did before when we had moles and grams, we're going to do that again. And then up here, we need to have moles of C3H8. Now, what do we got to know? What do we know between a mole and grams? That would be the molar mass. So we're going to use MM as just the abbreviation for molar mass. And we're not going to put in the numbers yet because we'd have to then calculate the molar mass. So I'm just going to use the word MM here. But remember, MM is the number of the molar mass of that particular this here. And I believe it's 44, but we're not sure. And then what we can do is 1 molar mass of something in grams is equal to 1 mole. So we're going to put 1 there. All right, so now we're pretty cruising along here. And again, what did we write here? We write moles of C3H8. Now, why do we write that there? Because, as we've always done, whatever's written here in this box, the unit goes down in the next box over to the right on the bottom. So whatever's written on the top goes to the bottom. Grams, grams. Moles, moles. Now, this is our molar ratio conversion. So this is where we use our balanced equation. So what are we trying to find? We can't go from moles of C3H8 to grams of water, which is what we're trying to find, right? The grams of water is what we want. So the next thing we have to do is put moles of water here. Moles of H2O. Now, we don't have any numbers here. And where do we get those numbers? We get those numbers from our balanced equation. So remember here, it says C3H8 plus 5 O2s. There's nothing here, so that's a 1. Right? There's always going to at least 1. So what coefficient goes with C3H8? That's 1. And where do we get that? We got that from right here. So that is where that 1 comes from. And what number goes with the word moles for H2O in our balanced equation? And that would be the 4. So here's the 4, so that would go here. So now we know that because it says 1 mole of C3H8 gives me 4 moles of water, and that's what it's telling me here. 1 mole of C3H8 gives me 4 moles of water. And then the last thing we need to do is, again, we basically keep doing the process. We have moles of water down here. And then how do we get back to grams? Well, we need that molar mass again. So we have molar mass of H2O. Or no, that would be 18. But now we put 1 mole of water is the molar mass of H2O. And there it is. That's how we set it up. So we haven't done anything yet. So when you do the math, eventually what's going to happen is these things are going to cancel out. These units are going to cancel out. And you're going to be left with grams of H2O. Now, you would set up this particular problem the same way, right? And you could do that on your own if you want. You would set up the same problem the same way using the boxes, right? Except for 25 grams here, that would go here. And then you're trying to find, and then these are the coefficients that you would put in here wherever you need to, the molar masses of the things that for this. So the same process, except the numbers will change because of this new thing. So let's look at the next page and show you what the answers are for both of the equations. Okay, so now this is the final answer for both of the problems. Now I'm just going to quickly review that we set it up exactly the way we did on the previous page, right? So the first thing we did is we had to find out what was our given. So I'm going to circle both givens. That's given for problem 1, and that's given for problem 2. And notice where they go. The first top box there. Then we just put it over 1, just like I've done before. And then the second thing we need to do is we need to convert to moles, right? So we need the molar masses, and those go down here because those are in grams. So there's 1 molar mass, and there's the other molar mass. Again, different materials, but we're converting oxygen, for example, down here, to moles of oxygen. C3H8 to moles of C3H8. Just what we did. Second thing is we need to do now is we've got to look at our molar ratio from our balanced equation. So that's that there. Again, same place as the other ones. Okay. Now, we have different materials that we want to find, right? This one says how many grams of water, and this one says how many grams of potassium chlorate, right? So we're looking for different ratios for different things, but the ratio there just comes out of the balanced equation. So potassium chlorate is this, and then water is this. So there's where those numbers come from. There's the number for that. There's the number for that. And remember, the other number comes from our given, and that would be for this one. That's the 3 here. And then for this one, that's the 1 here. So those where those come from, just like we did before. And then the last thing here is what we did is now we're converting back to grams using, again, the molar mass. The molar mass. And it's the molar mass of the thing we want, right? Because there we go. KClO3, that's what we want. KClO3. Water, water. So that's how it's done. The same process was done for both problems. You had different materials and different amounts, but exactly set up the same. Notice the setups. Given, convert to moles of given. Molar ratio of given to want, or want to given, sorry. And then convert back to grams for the want. Given, convert to moles of given. Convert from given moles to want moles. Convert back from want moles to gram moles. So this problem is going to be done by you to check for understanding. Now there are two ways that you can do the problem. You can do the problem as we just taught you with the one continuous process where the whole calculation is done at once, going from grams to grams. The other method, which is just as viable and just as correct, is to do three separate calculations where you take the given amount in grams, convert it to moles first, take that answer, convert it to moles of your want material using your balanced equation, and then take that moles of want material that you calculate and convert it back into grams of what you want using the molar mass. So three separate calculations, you need to do that 3 times, but it's perfectly acceptable to do it that way. So, but the end of the day is what I need to know is how many grams of oxygen are produced when 11.5 grams of NO2 are formed, right? So basically what you're going to do is, if I make 11 grams of NO2, how many grams of oxygen do I also make? So I'm going to show you the answer in a minute for the continuous process way. As long as you get the same answer using the 3 separate steps ways, if you want to do it that way, it's perfectly fine. Just show your work. So you're going to stop the video now, copy the information down, or work the problem on a separate piece of paper, then restart the video to get the answer. So stop the video now. Okay, so here's the answer. Now, the answer you should have gotten is 2 grams of O2. Now, the couple of things that you had to do in order to do this, you had to calculate or look up the molar mass of NO2, and there it is, right? I've given you it right here. Here's the molar mass of NO2, and you also had the calculator know what the molar mass of O2 was, and that's that right there. Everything else you can get from the problem or the balanced equation above, right? And I also told you should check the balanced equation, but for all these practice things, they are all balanced, right? And so let's just quickly review, where did you get these numbers, 1 and 4? Remember, there's a 1 here that you don't see, sorry. There's a 1 here that you don't see, and so that 1 is there. And then the other number, the 4, that's where that comes from. Everything else is pretty straightforward. This is your given. This is your molar mass of NO2, molar mass of O2, ratio from the balanced equation. Off you go. You should have gotten 2 grams. If you did, excellent. Continue with your work with the worksheet that I gave you, the couple of questions on there. Make sure you show all your work. If you didn't, go back and review what we just did. If you're still stuck or you're really confused, don't try to figure it out on your own. Get some help from one of your classmates or email me and we can set up some private one-on-one time.